In this video, we are going to find the value of k in each of the following cases. So let us start by the first limit. So here you see we have limit k times x to the power 3 minus k to the power 4 divided by x minus k when x approaches k, that is equal to k squared. So we would like to find the value of k in this case. So now let us write our limit. I mean the rule we are going to apply here. So we already know that when we have a limit x to the power m minus a to the power m divided by x minus a when x approaches a. So you see here, it's very important to note that here we have x approaches a, and now the rule says so that is equal to m times a to the power m minus 1. So this rule we are going to apply to find our value k in this case. But now we know that we need to write this expression in a similar format, this one. So what we do is the following. So we say, okay, now we take our limit, then we rewrite it here. So that is equal kx to the power 3 minus k to the power 4 all divided by x minus k when x approaches k. So this can be written as, so we can factor out this k. So then we will say, okay, we have limit when x approaches k. So here we would have k times x to the power 3 minus k to the power 3. So because we took just k outside, so when we multiply, then we get back here k to the power 4. So here we divide everything by x minus k. So and that will be equal to, so k is constant, we can take it out of the limit, so the limit does not depend on k. So then we have x goes to k, so the remaining will be here x cubed minus k to the power 3 all divided by x minus k. So now we can apply our rule. So here, I mean everything here of course is given that is equal to k to the power 2, right? So now look here, according to this rule, so here we have m is equal to 3 and a is equal to k, and we have exactly, you see that here we have x approaches a and here we have x approaches k. So now we just write k here, and then everything here will be equal to 3 a, which is k in this case, to the power 3 minus 1, which is 2, and now here everything is given to be equal to k squared. So now we see here that this is equal to 3, and then we multiply, here we have k squared, and then here we have k to the power 1, then that will be k to the power 3, and then this is equal to k squared. So of course we can divide by k squared here, and we'll divide by k squared here, so then that will be 1, and here this will go with k squared. So that means here, of course, providing that, I mean our restriction is k is not 0. So and here that we can do from the beginning of the problem, so k is not 0 in this case. So and then we would say the following here, we would have 3 k equal to 1. So and then that will lead to k equal to 1 over 3. So now this is the value of k for the first problem. So now let us continue with the second one. So the second one says we have a limit of sine radical k times x, then here everything is divided by x when x approaches 0. and that is equal is equal to half. So according to this, we are going to find the value of k. So we also know that we have a rule. It says whenever you have sine theta, for example, divided by theta, when theta approaches 0, that is equal to 1. So here we are going to apply this rule to find the value of k. So now we rewrite it again similarly as we did. So here we have limit as x approaches 0 sine radical k times x, everything here divided by x. So now look here, we have theta and we have theta, and this angle approaches 0. But now here we have radical k, x times x, and here we have only x. So then that must need to be similar in order to apply this rule. So what we do here, we can multiply by radical k and we divide by radical k. Now this will lead to the following here. So I mean this radical, we can rewrite it before we take it out. So say, okay, radical k sine, so of course here we would have radical k again times x divided by, and now here we multiply this by x. So what we get is we get radical k times x when x approaches 0. So now here we can take radical x outside of the limit because it is a constant, sorry, radical k. So we take it out of the limit, then we will have limit as x approaches 0. Then here we would have just sine radical k times x, radical k times x, and all divided by radical k times x. So now you see that here we have two similar angles. I mean, if this is theta, then theta in this case is equal to radical k times x in both cases. But now notice that here, and then the angle theta here approaches 0, as you see. So now here we have x approaches 0, but that is similar to say, I mean, when x approaches 0, if we multiply, I mean, both sides by radical k, like here by radical k and here by radical k, then what we will get, I mean, this times 0 is just 0 again, then we will get again radical k times x will also approach 0. So that means those here are similar. So then that will be equal to radical k limit. So now we can write radical k times x approaches 0, and now here we have this sine radical k times x. Sorry, sometimes I just write them a bit similar, the k and the x, but then it is clear from what I'm saying. So, and here we also have radical k times x. So now we are safe to apply our rule. But then before we apply our rule, it is given that here everything here is equal to half, right? So, and then here from our rule above, that is exactly similar to this one, then that is 1, right? So that is 1. Here this will lead to that. I mean, here we could say that radical k times 1, which is the limit here, that is equal to half. Then if we square both sides, then that will lead to the so we find this is equal to 1/4. So this is now our value k for the second one. So let us continue and also find the value of k for the following limit, the third one, and then we conclude this video. So the third one, we have limit 1 plus k times n to the power 1 over n. So when n approaches 0, then that is given equal to e to the power -2. So this is just Euler number. So, and here the rule that we are going to apply in order to find the value of k in this case. So we have limit when n approaches 0, 1 plus, let us just change it, I mean, to, instead of using n and n, or we can still use it, so it is okay. So that is equal to e. This is what we are going to apply to find the value of k in this case. So let us start. I mean, we need to write this expression, what is given here, up in this form here in order to be able to find the value of k. So what we will do is we can replace this by, let us say, u, for example. So we assume that u is equal to k times n, but then again, you see here, whenever we need to change the variable, also like integration by substitution and many things, then here we can also change this here, just under the limit. So if we use this, then we say the following. We say, okay, as n approaches 0 here, as you see, so that means this will also lead to the fact that u will also approach 0. So that is here obvious. When n approaches 0, then 0 times k will be 0, then u will also approach 0. So and then we can write as the following. And so now we change this to u, we also need to change this to write it in terms of u. So changing the variable must be everywhere in the limit. So here we can say, okay, u divided by k. So we divide both sides by k, and here we divide by k. So those would cancel out, and then this will equal to n. So but now we say, okay, 1 over n would be equal to u divided, sorry, is k now. So it's k divided by u. So and now we also change this. So now this will be k divided by u. In this case, we change it. So now we have everything. So we can write our limit as follows. So we say, okay, now we have limit 1 plus kn to the power 1 over n. When n approaches 0, then we are safe to say that. So this is similar to say that this limit when u goes to 0. So now we replace this by u. So we have plus u. And then here that will be replaced by k divided by u here in this case. And that is also equal to, so here that would be limit 1 plus u to the power, we can say it like this. We can say, okay, this is this when u approaches 0, but now everything here, I mean, is to the power k, because when we multiply the internal and external exponents here of this term, the summation, then we will get this again back. So, and now here we already know that, I mean, that is of course can be written as the following. We can still say, okay, this is limit, because here k is constant, so the limit does not depend on k. So u approaches 0, then this is 1 plus u to the power 1 divided by u. So everything here is to the power k, and that is already given here. So it is given by e to the power -2. So now we apply our rule, which is up here. So that is e. So now this will lead to the fact that from here we have, I mean, everything here is e, so we have e to the power k. So that means we have e to the power k is equal to e to the power -2. And then from here, finally, we would have, you see, we have here, we have the same base, and then those must be equal k and -2, and that will lead to k is equal to -2. So this is the value of k. Thank you very much for watching, and if you are interested in more videos, so please make sure you subscribe to the channel.